Hey guys, and welcome back to another video on the channel. In today's video we're going to be showing why integrating gives you the area under a curve. So let's just consider a set of axes like this, x and y, and let's just say we have some function here, okay? And let's just call this f of x. Now let's pretty much insert another function a of x, which gives you the area under a curve up to a certain point. So let's say it's x here. So for example, going from, let's say, the origin up until x, and at a of x it gives you that specific area in there. So what I mean is, if you plug in if I get the right color, if you plug in, for example, let's say a was 6 here, and you put in a of 6, that would give you that corresponding area there, okay? So what we're going to do is, alright, what if we just extended this idea really quickly? So what if I just, I'll just rub this out real quick. Let's say we've got that set up and we extend it, go a bit further, let's say some distance h, okay? So we want this area here. So if we increase the x value to h, this distance here is going to be h. So the area for this little interval here will be a of x plus h minus a of x, okay? So that will be the area of that interval there, the exact area, okay? Now let's take a look at this interval in two parts. So the first part, we can see we've got two different heights. We've got this height here and this height here. Now remind you that each of these heights here is x and x plus h. So if we look here, this here is x. So this height here is going to be f of x. And this height here is x plus h. And this height here would be f of x plus h. So what we have here is actually two little areas to compare. So if I rub this out real quick, we can compare the first area. For starters, this area here, where we have the height is f of x and the base is h. And now we've got this scenario here where we include the top bit, where the height is f of x plus h and the base is h. So this interval here, do you agree, will be less than this exact area here. And this area here, this rectangle, will be greater than this area here. So we can establish the following inequality. That this area, so this area here, is less than the exact area here. And this entire rectangle is bigger than our exact area here. So now we've got this inequality set up. Now that we've done that, we're going to divide everything by h. So we'll have f of x is less than or equal to a of x plus h minus a of x divided by h is less than or equal to f of x plus h, okay? So now we've got this, we're going to let h approach 0. So if we do that, this side here is going to turn to f of x, and all we can do is apply a limit in here, and this won't change because there's no h there, so it's independent. So if we let h go to 0, we get this following expression. Now, if something is less than or equal to something, or greater than or equal to something, it's actually equal to it. So in other words, f of x is equal to this here. Now this is the derivative of a of x. This is the first principle. So in other words, f of x is equal to a dash of x. So what that means is, if we were to undo its derivative, we would have to integrate. So in other words, the integral of f of x will be equal to your area function. Hence, integrating gives you the area under a curve. I hope you enjoyed this quick little video. Leave a thumbs up and share and like if you want more.